Hey everyone, it's Justin again. In the last video, we learned how elimination can be used to solve systems, but only if they're already set up a certain way. In this video, we're going to find out how to manipulate the equations ourselves so that they'll eliminate. We ended the last video with this system, but when we tried to use the elimination method, nothing eliminated. So what gives? Well, the problem is that nothing zeroed out. So in order to prepare this for elimination, our goal is to manipulate two of the terms to be exact opposites so that they'll zero out when we combine equations. But how can we do that? Well, it's a lot easier than you might think. We multiply. More specifically, we multiply at least one of the equations so that a term in that equation becomes the opposite of a term in the other equation. I know it sounds complicated in words, so let's have a demonstration. In this system, if we multiply the first equation by 2, we get 6x minus 4y equals 12. So while this equation doesn't seem particularly important, what happens now if we include the second equation with it? Do you see it now? The y terms in the equations are opposites, which means they'll zero out. So let's try it. If we add the equations together, the y term is eliminated, and we get that 7x equals 14. Now we'd be able to finish solving the system. I'll let you do that part on your own as practice. This video is going to be focused just on manipulating the equations so that elimination works. Take a look at this system and see if you can figure out what to multiply by. Alright, that was kind of a trick question because there are actually two answers. If we were trying to cancel the x term, we'd multiply the bottom equation by -2. So why -2 instead of +2? Well, if we multiply by +2, the x terms would be exactly the same, so they would not eliminate. But if we multiplied by -2, the x terms become opposites, and they will eliminate. Remember how I said there were two ways to prepare this system for elimination? The other way is by manipulating the y terms. So what would we multiply by to make the y terms eliminate? Hopefully you said multiply the top equation by -6. This creates a +6 on the top that eliminates the -6 on the bottom, leaving us with -22x equals -19. I'll leave it up to you to finish solving this system, but I'll give you a hint. Check out the two equations we got after eliminating. Can you figure out what to multiply by here? Yeah, this one's a little harder. Sometimes just multiplying one equation isn't enough to prepare for elimination. So you have to multiply both equations by something. We know that to eliminate, you need a positive and a negative. So we'll try to eliminate the y since they already have the opposite signs we need. The big question is, what do we multiply by? This is where an old concept, least common multiple, comes into play. What number is a multiple of both 2 and 3? I've got it. If we multiply the top equation by 2 and multiply the bottom equation by 3, now the y terms will eliminate. If we wanted to eliminate the x terms instead, we would have to make sure to make one of them negative. We could either multiply -3 on top and 2 on bottom, or multiply 3 on top and -2 on bottom. The numbers are the same. The only difference is the negative on either one or the other. So we get a -6 and a +6. It can seem a little complicated, but remember the goal. Make opposite terms so they'll zero out and eliminate. All right, one last example, and this one's going to be a doozy. This time, the equations aren't even in the same form. We can't eliminate unless everything is lined up nicely, so our first job is going to be to move the pieces around. Since the first equation is already nice and neat, we'll leave that one alone and make the second equation match. First, let's distribute that 4. There we go. It looks better already. I'm leaving the original system up in the corner so that we remember where we started. Next, let's add 3 to both sides. There we go. Now the y terms, equal signs, x's, and constants are all lined up. Now we can multiply to get ready for elimination. So what should we multiply by? If we multiply the first equation by -2, then we can get the x terms to cancel, and we'll be well on our way to solving this system. All right, so what have we learned? Before you can use the elimination method, like terms have to be lined up. If they aren't, you'll have to move them around. And once the terms are lined up, if none of the terms are ready to eliminate, multiply at least one of the equations so they will. Once these criteria are met, you can use elimination to solve the system. Elimination is an extremely useful method for solving systems, but you can only use it if the system is set up a certain way. But now you know that it's possible to manipulate systems yourself in order to get them ready for elimination. In the next video, we're going to continue talking about manipulating systems. See you then.